All right, good afternoon, geometry. It's Mr. Mays. It's the 17th of November. We're doing chapter 4, section 4.4, congruence and transformations. So I picked a few problems out of this section to highlight some of your new theorems you have. And in particularly, I want to highlight this theorem right here. Okay, that'll be the third problem that I do today. But first, let's look at just a couple of problems where we have to figure out what happened. We have to decide whether the shapes that we have are congruent to each other. So I picked number 8 and 10. Now read the directions carefully. It says, determine whether the polygon with the given vertices are congruent. Use transformations to explain your reasoning. And I know that some of you will just simply answer yes or no, and you will not actually answer the question because you failed to use transformations to explain your reasoning. So I'm going to look at number 8 and number 10 from this section. So number 8. So I wrote down number 8. Here it is. And I looked at the points. So I stacked them on top of each other so that I can actually look at the corresponding vertices. Notice that point W corresponds to C, X to D, Y to E, Z to F. So the question is, are they congruent? Well, if I could identify a rule or two or three, in this case it's going to be 2, to describe the transformation, then I can say yes, they are. So I look at point W and I look at C. I see a pattern. I notice that there's a -3 and a 1 in W, and then a -1 and a -3. It would appear that the Y's and the X is something going on. Okay, and then if I look at X and D, and then if I look at Y and E and Z and F, yes, it looks like A went to B and then B changed sign. Now we have a rule for that, don't we? So we look for this pattern or a constant increase or decrease. I see the pattern AB. It looks like we went to negative BA. So if you go to page 191 and look at those rules for rotation, that looks like a rotation, you will say, hey, we have a 90-degree rotation counterclockwise about the origin. Okay? So let's see what we did. So I decided to graph this to see what it really looked like. That's what it really looks like. And sure enough, I picked on the points there. You can see where I did my little lines here. See between W and C, because those are the corresponding vertices there. And look at that. I do, in fact, have a 90-degree angle. I know it's 90 because I look at the slope from this to the origin is -1/3. And if I look at the slope of this line from its counterpart to the origin, I have a slope of 3. They're perpendicular. That implies a 90-degree rotation. So comparing those segments, I noticed that the origin to W and then the origin to C, those slopes, -1/3 and 3, they are in fact perpendicular. That is definitive proof that we have a 90-degree rotation. Okay, so that was number 8. Now let's look at number 10. Same thing. I look at the points, and the first thing I notice is the X value for each corresponding point are opposite. Well, 0, 0, but then it goes 1 to -1, 4 to -4, and 3 to -3. Oh, okay, that's worthy of note. And then I look at the Y values from 0 to -5, from 2 to -3, from 2 to -3 to 0 to -5. The Y values are decreasing by 5. I have some rules about this, don't I? So I notice that the X's are opposite, and I notice that my Y's are dropping by 5. So which comes first? A reflection in the Y-axis, because notice the X's values are opposite, so that implies a reflection in the Y-axis. Or did I drop everything by 5 on the Y's? A translation down 5 units. Well, let's graph it and see if it really matters. So there it is. There's the original form, A, B, C, D. And if I graph it, they are in fact congruent. Notice the corresponding parts. And if you'll notice, a boo-boo. If you notice that this got reflected and dropped, if you reflect it across the y-axis and then drop it 5 units, you will have your resultant shape. So that is the transformation that occurred. It's a reflection about the y-axis and then dropped 5 units. Okay? Okay, now, number 16. Number 16 looks pretty innocent. It says, find the angle of rotation that maps A onto A prime. Okay? Now, here is 16. Notice that A is the blue, A prime is the red, A double prime is the green. I have 2 lines, lines K and line M, and they intersect at a 15-degree angle. Now, this theorem, it says, right here, reflections and intersecting lines theorem. If lines K and M intersect at point P, then a reflection in line K followed by a reflection in line M is the same as a rotation about point P. Now, what kind of rotation? The angle of rotation is 2 times the angle where x degrees is the measure of the acute or right angle formed by lines M and K. Well, I would like to try to explain what is really going on here. So this is what I did. I took 2 lines, M and K. I made them at a 45-degree angle. I did that because I have some really nice slopes of 1, okay? And that way the perpendicular slopes are easy to calculate also. So I started with my shape. I have a triangle, ABC. Now notice that I labeled the actual coordinates for point A, assuming that P is in fact the origin, okay? P is the origin. So here's this. So now that theorem says that if I have 2 lines that intersect at point P at the given angle 45 degrees, it is the same as first reflecting your shape about the line K. So I did that. I reflected the shape over the line K so that triangle ABC reflected in line K went to A prime, B prime, C prime. Okay? And now once again, I only labeled the values for point A. Notice the reflection rule. I started out with a 1, 9 and I went to a 1, -9. So that's the first step. Okay? And then it says that if you reflect that about the line M. So I took this and then I reflected it about the line M. Okay? See my little perpendiculars? Okay? Now once again, if I reflect it in the line, notice what happened to the values of the coordinate A. Okay? And went from -9 to 1. Okay? So what did I do? I started with this. I reflected it in the line K, and then I reflected that in the line M. Like this. Now what the theorem says that doing all of that is exactly the same as rotating that shape formed an angle from a point to P to A double prime is the same angle as doubling this angle right here. So, is that what really happened? It is in fact what really happened, and you can look at the values of A and A double prime. Notice that I constructed a line from P to A and then from P to A double prime. It is in fact a 90-degree angle. I know it's a 90-degree angle because the slopes of the lines are opposite reciprocals. I can do that for B to B prime and from C to C prime, starting at the origin, point P, going to C, from the origin to C prime. They all form 90-degree angles. Now I would expect this because that's my rule for a 90-degree rotation. A goes AB, -B, A. So all that theorem says is that if you have a shape and you have 2 lines that intersect, that you can make a reflection across the line K and then reflect that across the line M. It is the same thing as rotating the shape counterclockwise twice the measure of the angle. That's all that theorem says to you. So, that's what I got for this section here. If you have any questions, please feel free to ask. And oh, by the way, some of you are obvious to me, you're copying answers and you're really not doing the work. So please refrain. Do the work and then check your work, because I'm expecting you to check your work. I mean, that's how your homework is actually getting graded. You're basically grading it yourself. You're making the corrections as required. All right? Okay. Until next time, Mays out.